Okay, this is the 4-3 notes for binomial experiments. These are special type of probability distributions. A probability experiment, it is one that is fixed number of trials, and each trial is an independent of the other trials. It's very, very important. You have to prove its independence before you can do this. There are only two possible outcomes. That's the second thing that's most important. You get a success or a failure. The probability of success is the same for each trial, and the random variable x counts the number of successful trials. So if we have a situation where you have a certain surgical procedure has 70% chance of success, the doctor performs the procedure on 10 patients. N is your 10 because that's how many patients are the total number of trial choices. And 0.7 is your P. It is the probability of success. So each surgery represents one trial. Each of the 10 surgeries are independent because they're not on the same people at the same time. There are only two outcomes, successful surgery or unsuccessful. The probability of success is 0.7, and it is the same for each trial because the same surgeon is doing it. X represents the number of successful surgeries, and they can be anything from 0 being successful up to 10 and everything in between. On our calculator, we know that menu 5-3 is the shortcut to do a combination, and the probability formula is a combination of n comma x times the probability raised to the number of x times 1 minus p, or q, raised to the n minus x, and q is 1 minus p. So you can use lists and spreadsheets on your calculator to do this kind of problem if you need to do it for all of the different groups, or you can use the equation just to do one or one individual, depending on what the question is asking. So a card is selected from a standard deck and is replaced, which makes it independent. This experiment is repeated a total of 5 times. Every time it's pulled out, it's put back in. We want to know the probability of picking 3 clubs, exactly 3 clubs. So our trial is drawing a card from the standard deck. Our success is that we drew a club. Our failure is that we didn't draw a club. There are 5 trials, and the probability of getting a success is there's 13 clubs in the deck out of 52, so we get a 0.25 success. Q is 1 minus P, which is 0.75 failures. And how many we want to make to be able to reach our goal is 3. X is 3. So the probability of getting exactly 3 is combination of 5 comma 3 times 0.25 raised to the third power, because that's how many we want to get, times 1 minus 0.25, or 0.75 raised to the 5 minus 3, which is the number of failures that would happen. In other words, combination 5, 3 times 0.25 raised to the third power times 0.75 raised to the second power. So in our calculator, this is what that would look like. Menu 5-3, 5 comma 3, so n comma, how many we're choosing, n comma x, times our probability, which we can put in as a fraction. We know that we had 13 out of 52. That would be our probability, raised to the how many we want to make be successful. So 3 successes times 1 minus, again, 13 out of 52. This time raised to the number we're doing minus how many successes we needed. So that gives us our number of failures. And then we'd hit enter, and we would get 45 out of 512, or 0.087891. So that's what that would be. Okay. Using the binomial formula, we can also use a setup in your calculator that's a different choice. We just did the formula itself. If we use menu 65A, we can plug in our number of trials, which our previous example was 5. Our probability of success was 0.25, or you could put 13 over 52 in here, just like I did on the previous question. And how many successes? And then hit OK. And it will fill it in like this. Binomial PDF probability of 5, given the probability of success of 13 out of 52 for 3, and we get the same answer. Okay, so again, the question becomes, a card is pulled out, it's replaced, that makes it independent. We want a total of 7 trials, that's N is 7, and we want exactly 2 kings. So our N is 7, our P is 4 out of 52 because there are 4 kings in the deck. Our Q is 1 minus 4 out of 52, and our X is 2. Now, if you use menu 65A, you do not need to know what Q is. Okay, but if you reference the chart, your reference chart for this type of thing, which is this version of the equation, N over K, like that is how they write. That's how you would actually see a combination. So this is the combination. This is the same equation that I'm just showing you. If you're going to write down this equation, make sure you fill it in the way that it's supposed to be put in, just like I did on the previous example. But you can shortcut your work by going ahead and using menu 65A, or you can type it in to your calculator the long way. And then you get to your answer. Either way, you'll get the same answer. Let's say we want to do the probability and fill in a probability distribution chart. Here is where you would use a listen spreadsheet. So we're going to go to New, pick No, and go to Listen Spreadsheet. And you're going to put into the column the equation that you're needing, but you need X here. So you're going to put X 0, 1, 2, 3, 4, 5, and 6. And then in the second column, which is our probability, we're going to put in the equation that we have here. Okay. To do NCR in our calculator, you're going to put equals, type in NC, and then I don't remember how I did this. Enter column B, NCX. That's right. NCX. Oh, I know what it is. You type in NCR. Sorry. It's been a while since I did this. And then you're going to put in your N, which is in this case 6, comma, you're going to type in X. And then times your P, 0.63, raised to the X. And then times 1 minus 0.63 raised to the 6 minus, again, X. Okay, so you have to fill in your N, you have to fill in your P's, but your X's can stay the same. So here at the bottom, you can actually see the entire equation fully written out. Okay, and then you hit enter, and you're just going to again ask you for a column or variable, and then say okay, and it will give you all of it filled in, and then you just round to whatever they tell you to round to. Okay, so that fills out those kind of problems. Or you can do it by hand by going and doing menu 65A, put your NP and X in, and fill in yourself. That works too. Okay, so finding the binomial probabilities using the formula. Again, I'm showing you how it would look in the calculator. So for this part right here, again, you use menu 5-3. And on your calculator, it will read like this, N comma X is how you would have it in the calculator. If you're doing it in the the list and spreadsheet, you're going to put in it in this formula. So that's what it would look like in the formula. Now, once you have found your probability, you need to remember to represent that as a probability percentage. There's a 34.5% probability that exactly 2 of the 5 teachers respond yes when asked if gaming is their favorite leisure activity. That goes back to the original question. It references what the N and the R X is, and it references what the situation that they were talking about. You can also use this to create a probability distribution chart, and that would be a simple, again, using your list and spreadsheet. Here's example again of what you would type in, and then drawing your picture. Just make sure that you label all your graphs. Okay, last step is once you've determined you have a probability distribution, then things get really easy because the mean, variance, and standard deviation formulas are way easier than if it's just a probability distribution. If it's binomial distribution, then all we have to do to find mean is take your n times the probability of success. To find variance, you do the probability of n times the probability of success times 1 minus the probability of success, or n times success times failure. And then square root of that will give you your standard deviation. So once you know it's a binomial probability, once you've gone through that checklist that we started with, then you can immediately go ahead and find the mean, median, variance, and standard deviation, and they're very easy. So we have a rainy day in August in Seattle, Washington, is a 38% chance of rain. Rainy days, that's the probability of success. So the non-rainy days is 62%. 31 days in the month. And so our mean number of days of rain is 11.78. Our variance is 31 times 0.38 times 0.62, 7.306, plus or minus 2.07. So on average, there is 11.78 rainy days in August. Values more than 2 standard deviations, plus or minus 5.405 from mean, are unusual. So days less than 6.3 or greater than 17.18 are going to be unusual. So if you're trying to decide if you're going to be visiting there while it's raining, you can decide, well, it could be less than 6 days. That's going to be an unusual situation. More than 17 days is going to be an unusual situation. Okay, that's all of the sections.